Hello, in this video I will be talking about exponential and logarithmic functions. For exponential functions, they have the form y equals b to the x, where b is a positive value and it's not equal to 1. If it were equal to 1, then the whole function would just be a constant 1. So the shape is either going to be, if b is greater than 1, it's going to be a exponential growth, right? It's going to be growth if b is greater than 1, and it will kind of look like this. It will just kind of skyrocket up. Let's see, like that. And if it's decay, there's some pictures down here too. If it's decay, it's going to be coming down this way and getting smaller if b is less than 1 but greater than 0. The domain is all real numbers. You can plug in any number, right? But the range will not be all real numbers, because if b is greater than 0, you can't have any negative numbers here. So it will just be values above the, well, if it's simply b to the x, it's going to be above the y-axis, so y will be greater than 0. Okay? And it can never be equal to 0, because b is never 0. So it's got to be something greater than 0. Now you could tweak the function by transforming it, and it might be greater than a particular y value, a positive y value, like y is greater than 1. Like for example, in this exponential function here, y is we're adding 2, so we're really starting over here, and we can't go below the y equals 2 line. So technically the range here would be, y is greater than 2, right? And the domain, again, would be all real numbers. So it depends on the transformation, but generally y is greater than 0 or greater than some positive value. The equation of, well, the asymptote here would be where it's approaching, right? So in this case, it's going to be approaching y equals 2 or some y equals k value. If you're not adding anything to the exponential, then it will be y equals 0. If you are adding something like 2, it'll be y equals that, whatever that value is. And it's easy to generate a graph of this, right? You'll notice if you're at -2, let's say -2 here, you're going to be really close to 0, and then a little bit higher up, right? At 0, it'll be equal to 1, right? And then it'll go up to 10, and then it just keeps climbing higher. So the graph generally will look like that if it's a growth function, right? It might be easier to see this also in Desmos. If you're in Desmos, I would just, you could just graph any exponential function and kind of explore it. Y equals 10 to the x. You can see it has this growth shape to it, and it gets really large really quickly. Again, down here are some examples. This is a decay function because it's a fraction. It's greater than 0, but it's less than 1, so it's going to shrink down. It's going to get smaller and smaller. These are two growth functions. Let's look at logs now. The shape of a log function looks like this. It's a concave down, and logs, on the other hand, grow very slowly. They kind of look like this. Right, like that. And they have an asymptote too. They can't go below. Hold on, let me just graph this. They're going to approach the y-axis as x gets closer to 0. So the domain would be x has to be greater than 0, can't be equal to 0. And the range would be from all real, would really be negative infinity to infinity. Right? You could think of it as 0, infinity. Actually, it's open, and then infinity. The asymptote would be the y-axis here in this case, so that would just be x equals 0, right? And this would be, this is a table for the log base 10, right? And why don't we go into Desmos and graph that too? It's actually the inverse of this, 10 to the x, log base 10. Whoops. There you go. It kind of looks like this. It's a little hard to graph those small numbers on the table. I'll just take a snapshot and put it into the PDF here. Okay. All right. For the function 1 over x, this is a rational function. The shape here actually looks similar to an exponential on one side of it. Let's take a look at the graph in Desmos. It looks like a kind of decay function here, because as x gets larger, this quotient is going to shrink down to 0, right, as x goes to infinity. But if x is negative, you wind up with this piece of the graph, right? Again, as x gets larger in the negative directions, it's going to go to 0. It's going to approach the y-axis, the x-axis. But as x gets smaller, it's going to approach negative infinity this way. So it has this shape to it. It's hard to describe the shape with one word, but it would be something like, you might want to just be able to sketch it out where it's like, looks like that, approaching 0, then coming from 0, approaching negative infinity that way, right? There's an arrow up this way too, towards positive infinity. So the domain is really everything except 0, right? So you can't have 0 in here. So x cannot be 0, but you can plug in any other number. So you can see there's an asymptote at the y-axis here. So it's x equals 0 is an asymptote. The range is all real numbers from negative infinity to infinity. As you can see, it's going to go up to infinity and down to negative infinity here, right? And we would write this x can't be 0. Well, that's kind of a disjoint set, so we'd say it's from negative infinity to 0 union 0 to infinity would be the domain. Here's an example of a table of values. You can get a table of values also in Desmos by clicking on this gear button and hitting that table. And you can make a table of values here, and it'll plot the points on the curve for you. And finally, the squared reciprocal. So the only difference here is that we won't have any negative numbers, right? Won't have any negative numbers. So this one looks virtually identical to this one on the right side of the y-axis. So if I just hit a square here, right, you can see all the values are positive. All the y values are positive. As you go in the positive x direction, you're squaring all these numbers and inputting it in. It's going to get a smaller and smaller ratio, so it's going to approach 0 this way, right? And let me see if I can change the graph to look a little different. A little different here. Might be a little better. Yeah, so these are going to skyrocket up to infinity on either side here. And as you get smaller and smaller and smaller, right, then 1 divided by an infinitesimally small number is going to be infinitely large. So let me grab this snapshot and put it into the notes. here, you can, let me put some arrows on here too so we know that this is going to keep going up towards infinity, and this is going to keep approaching 0. So in this case, the domain, again, is every real number except 0. You can plug in anything into here except 0. So it's going to be negative infinity to 0, union 0, infinity. We're just taking out 0 there. So x cannot be 0. And the range is now going to be from 0, not including 0, because it never actually gets to 0, just gets really, really small, to infinity, right? Because there's no negative numbers into here and that can be outputted because of the square. And the asymptote here, well, there's two asymptotes. There's the y equal 0 and x equals 0, right? I guess it's the same here. The x-axis is also an asymptote, so it's y equals 0 and x equals 0. So the shape looks kind of like that, right? Okay. I hope this was helpful. Let me know if you have more questions.